Yes, hello students. Welcome back to physics session. I hope you all can hear my voice. Yeah, this is Sandhya. Today we are going to discuss electric charges and fields, important concepts, especially calculation of the net force and net electric field due to system of charges at any point in that system. Okay, okay students. Uh, yeah, just a few brief about the app here. If you want to join our free live classes daily, you can contact, and for any admissions, you can inquire at Spark Academy app. You can join, you can download our app. Yeah, yeah. As students, now our topic is for the first concept is Coulomb's law, which gives the electrostatic force between the charges. Here you can observe there are two charges Q1 and Q2 which are separated by a distance r. The force between them is directly proportional to product of the charges and inversely proportional to square of the distance between them. Okay. So by reducing the proportionality, we can write the force between the two charges will be equal to kq1 q2 by r square. This force, if we are given with the same charges, if we are given with the same charges, it will be repulsive. So kind of force exists between the charges, you can say. If there are same charges, repulsive force will exist. Opposite charges, OPP means opposite. If opposite charges are given, attractive force will exist between them. So if they're asking direction of the force, we need to follow this point. And in this equation, k is nothing but 1 by 4 pi epsilon naught. And this formula between the charges, if no medium presents, no medium presents means for air. So that k value we can take it as 1 by 4 pi epsilon naught, which is equal to 9 into 10 power 9. In case if medium present between the charges, then the force when medium present between the charges, definitely force will be affected if medium present between the charges. That will be equal to force when it is in the air, means between the charges no medium present, that force by that medium value. Here k is nothing but dielectric constant or the medium value. It can be written as 1 by 4 pi epsilon naught k into q1 q2 by r square. Actually, we need to take epsilon naught into k is nothing but epsilon. You need to understand here epsilon naught is the permittivity in free space or in air. If you are taking epsilon naught into k, which is in the medium, we are finding that force when medium present between the charges. If they kept in the medium, any other medium. So some constant is introduced between them. that medium constant value is given, you need to take epsilon naught into K. Okay, and one more relation. If a dielectric medium of thickness is given, you can observe this diagram clearly. Two charges Q1 and Q2. Between them, yes, yes, students, I hope you all are following. Here, Anushree. Yeah, she is telling hi. How are you, ma'am? Yeah, good, good. Doing good. How are you? Yes, Anushree, after a long time. It is scheduled on this day. Okay. I hope you are following it. Okay. You can see if a dielectric medium of thickness T is given, then the force between the charges, we can use directly this relation. Okay. So force between the charges will get affected if charges are changed, if separation changes, like this relation. If magnitude of charges changed, force will be affected. If separation changes, force will be affected. If medium changes, force will be affected. If medium thickness is given, actually this table and this table, like this box. If medium value is given, directly this formula we can use. Substitute that medium value, you can find force between them by substituting magnitude of charges, so separation and medium value. And this box, by giving medium thickness, directly using this relation, you can find. The only thing you need to practice, which type of questions can be asked, how the force will be affected by changing the magnitude of charges and by changing the separation between them. So let us look at that type of questions. Anushree, you want in Telugu? Okay, okay. I hope you understood till now. ఇనిషియల్గా టూ చార్జెస్ మధ్య దెర్ ఈజ్ నో మీడియం. అంటే మీడియం ఈజ్ నథింగ్ బట్ ఆల్ ఆఫ్ సడన్ నేను ఇక్కడ ఈ చార్జెస్ని వాటర్లో డిప్ చేసిన లేదా సమ్ గ్లాస్ స్లాబ్ని ఇన్సర్ట్ చేసిన డెఫినెట్లీ ఫోర్స్ విల్ చేంజ్ బిట్వీన్ ద చార్జెస్. ఇఫ్ నో ఇఫ్ నో మీడియం ప్రెజెంట్, యూ నీడ్ టు టేక్ ద ఫస్ట్ ఫార్ములా, దట్ ఈస్ ఫర్ ఎయిర్. K వాల్యూ అనేది కాన్స్టెంట్ ఇక్కడ. ఇట్ ఈస్ ఆల్వేస్ ఈక్వల్ టు 1/4 pi epsilon naught. దిస్ వాల్యూ యూ కెన్ సబ్స్టిట్యూట్. డైరెక్ట్గా మనం K బదులు ఆర్ 1/4 pi epsilon naught బదులుగా 9 into 10⁻9ని సబ్స్టిట్యూట్ చేయొచ్చు. సో దిస్ ఇస్ ఫస్ట్ ఫార్ములా ఫర్ ఎయిర్. ఇఫ్ మీడియం ప్రెజెంట్ అండ్ ఓన్లీ మీడియం వాల్యూ ఇచ్చేసి calculate the force between the charges ante you can take 1/4 pi epsilon naught into K. So K of that particular medium they can give. It depends upon the medium, nature of the medium. Okay na? So in case water lo insert chesaru charges which are at certain separation. So K of that water can be given. They kept in a glass blocks, one glass box. అప్పుడు ఆ గ్లాస్ యొక్క మీడియం వాల్యూ కాన్స్టెంట్ వాల్యూ ఇస్తారు. బై సబ్స్టిట్యూటింగ్ దట్ యూ కెన్ ఫైండ్. ఇన్ కేస్ వన్ స్లాబ్ ఈజ్ ఇన్సర్టెడ్, ఒక టీ థిక్నెస్ ఉన్న ఒక గ్లాస్ స్లాబ్ని తీసుకొని టూ చార్జెస్ మధ్య పెడితే విచ్ ఆర్ ఎట్ సెపరేషన్ ఆర్, దెన్ వాట్ ఈస్ ద ఫోర్స్? ఈ టూతో నో ప్రాబ్లం, డైరెక్ట్ ఫార్ములా రిలేషన్స్ సెకండ్ థర్డ్ డైరెక్ట్ యూజింగ్ ఫార్ములా యూ కెన్ ఫైండ్ ఫోర్స్ అనేది ఫైండ్ చేయొచ్చు నువ్వు. The only thing here, ఇప్పుడు charges change అయితే ఏంటి, separation change అయితే how the force can affect, how it will be affected. Okay na? So let us see that case. Here I have given 3 model questions about relation between force and charges, force and separation between them. So look at this. We are given with 2 point charges, 3 microcoulomb and plus 8 microcoulomb. Same charges are there here. Okay, repel each other because of same charges. Each other with a force of 40 Newton. If a charge of minus 5 microcoulomb is added to each of them, then the force between them will become. Initial ga సేమ్ చార్జెస్ ఉన్నాయి. ఫోర్స్ ఎంత అన్నారు? వీ నో దట్ ఫోర్స్ ప్రపోర్షనల్ టు లైక్ Q1 Q2. ఓకే, విత్ ఇనిషియల్ చార్జెస్. ఇనిషియల్గా మనకి ఇచ్చిన 3 మైక్రోకూలుమ్ అండ్ 8 మైక్రోకూలుమ్తో కెన్ వి రైట్ F is equal to, whereas it is proportional to product of the charges, I am taking proportionality only. ఇక్కడ proportionality తీసుకొని డైరెక్ట్గా క్యాలిక్యులేట్ చేయొచ్చు. మనకేమి కాన్స్టెంట్ అడగట్లేదు. హౌ ఫోర్స్ అనేది ఎలా ఎఫెక్ట్ అవుతుంది మాత్రమే అడుగుతున్నారు. 3 into 8 into micro means it's a prefix value, you need to take it as 10 power minus 6. So you need to substitute it as 10 power minus 6 into minus 6 will become 10 power minus 12. So it is giving F proportional to, it is 24 into 10 power minus 12. ఇప్పుడు ఏమంటున్నారు? ఇఫ్ ఏ చార్జ్ ఆఫ్ -5 మైక్రోకూలుమ్ ఈజ్ యాడెడ్ టు ఈచ్ ఆఫ్ దెమ్. ఇప్పుడు +3 -5 హౌ మచ్? సో న్యూ ఫోర్స్ని నేను F డాష్ అని తీసుకుంటున్నాను. ఐఎమ్ టేకింగ్ ఇట్ యాజ్ F డాష్. +3 -5 because we are adding some amount of charge next. It will become -2 into +8 -5. It will become 3 only, na? Yes. Into 10 power minus 12 common because both are microcoulombs only. So can we write new force is equal to, is proportional to -6 into 10 power minus 12. But they're asking what, then the force between them will become -5 మైక్రోకూలుమ్ యాడ్ చేసిన తర్వాత F డాష్ వాల్యూ ఎంత? సో ఐఎమ్ టేకింగ్ లైక్ F డాష్ బై F. F డాష్ వాల్యూ వచ్చేసి -6 into 10 power minus 12 by 24 into 10 power minus 12. It cancels. Actually F dash by F value we are getting it as -1 by 4. కానీ మనకి F వాల్యూ ఇచ్చేసారు. 3 మైక్రోకూలుమ్ 8 మైక్రోకూలుమ్ చార్జెస్ ఉన్నప్పుడు ఫోర్స్ బిట్వీన్ దెమ్ వాల్యూ ఇచ్చారు, అంటే F వాల్యూ ఇచ్చారు, దట్ ఈస్ 40. ఇప్పుడు F డాష్ ఏమవుతుంది? దట్ ఈస్ ద న్యూ ఫోర్స్ వెన్ -5 ఈజ్ యాడెడ్. సో ఇట్ షుడ్ బి -40 by 4. సో ఇఫ్ యూ క్యాన్సిల్, ఇప్పుడు డివిజన్ చేస్తే ఏమొస్తుంది? వీ విల్ గెట్ ఇట్ యాజ్ -10. సో ఆన్సర్ షుడ్ బి, they given with the sign. Okay, you should be careful by taking that. Actually sign indicates direction of that force also, whether it is repulsive or attractive, that way. So here we are finding the magnitude of the force with sign. So you need to substitute what are the charges given. Yes, Anushri, option A, good. Come to second question. Force between two charges 0.06 meter apart is 5 Newton. Okay, when they are at 0.06 meter distance, force between them is how much? 5 newtons. If charge is moved towards the other by 0.01 meter, then force between them will become, initial ga 2 charges unnai, at what distance? 0.06. So ee 2 charges, let it be like Q1 Q2. అవునా? 0.06 మీటర్ డిస్టెన్స్లో ఉన్నప్పుడు ఎఫ్ వాల్యూ ఇచ్చారు 5 న్యూటన్స్ అట. ఇప్పుడేంటి, ఈ 2 చార్జెస్ దే ఆర్ మూవింగ్ టువర్డ్స్, అంటే ఐ కెన్ సే హియర్ దిస్ సైడ్ ఈచ్ చార్జ్ ఈజ్ మూవింగ్, అంటే Q1 0.01 మీటర్ అండ్ Q2 ఆల్సో 0.01 మీటర్. అప్పుడు ఏమవుతుంది? సెపరేషన్ విల్ డిక్రీజ్. ఎస్ నో? సో ఇప్పుడు ఎఫ్ డాష్ ఏంటి? ఇక్కడ మనం ఏం రిలేషన్ తీసుకోవాలంటే, మన దే ఆర్ నాట్ టాకింగ్ అబౌట్ ద చార్జెస్, దే ఆర్ టాకింగ్ అబౌట్ ద సెపరేషన్ బిట్వీన్ ద చార్జెస్. సో డెఫినెట్లీ సెపరేషన్ చేంజ్ అయితే ఫోర్స్ విల్ బి ఎఫెక్టెడ్. సో టేకింగ్ దిస్ రిలేషన్ I can say F dash by F we can take a or else you can write this relation initially if it is f, next will be f dash, will be equal to, as it is inversely proportional, it should become r2 by r1 whole square. Nothing but when f force between them, separation is r1. R1 ante 0.06. When they approach from each side 0.01 meter, what will be R2? Something will be reduced now. From each side 0.01 meter is reduced ante 0.02 total separation is reduced from the 0.06. ఇప్పుడు R2, can we take it as 0.04? Now substitute here. So I can write phi by f dash is equal to 0.04 by 0.06 whole square. Taking separation, yes, Syed Ayas. Good evening, Syed. Yeah, so follow the questions here. We need f dash value. You can see in this ratio, decimal places are equal. Directly, we can write it as 4 by 6 whole square, nothing but 2 times, so 3 times. 2 by 3 whole square means we will get it as 4 by 9. 5 by f dash value is 4 by 9. I am taking this side. Come to this side. Then f dash will be equal to, I think it is 40 by 45 by 4. This ratio will become reverse. We need to find the new force when the separation is changed. Is it? Then which answer? Anushree, can you answer it? $11.2 I can say. So you can go with the directly with the option B. Okay. Come to third. There are two charges of 40 microcoulomb and minus 20 microcoulomb. You can see opposite charges are there. Okay. Are placed at a certain distance apart. So initially they are at certain distance. They are touched and kept at the same distance. So initially at certain separation, now they touched and kept at the same distance. So they are in contact. Immediately you should get the idea. ఎప్పుడైతే టూ చార్జ్డ్ బాడీస్ కాంటాక్ట్లో ఉన్నాయి అంటే charge distribution, like you and your friend, one you are having 100 rupees, your friend is having maybe 20. So you want to buy something which costs the both both of you have to buy the same thing, so you must have the same money, then you will share the money. Yes, no? So to become equal, like that, two charged bodies are in contact. ఎప్పుడైనా different charged bodies ని మనం contact లో ఉంచితే total charge ni they will share each other. The total charge will be shared by each body equally. Nazir, you are giving answer for second question, 11.25. Yes, Nazir, it is 11.25. I'm talking about third question. I'm taking initially Q1 is 40, Q2 is minus 20. So can we say F is proportional to like 40 into 20? Because force proportional to product of the charges. Of course, microcoulomb is given. I'm just taking magnitude in terms of 40 and 20 only. Now F dash. F dash, separation is not changed. So I'm not taking by r square value. They are touched and kept at the same distance. When they touch each other, total charge will become 40 minus 20 will be equal to 20. So total charge is being equal to 20. So each can be shared. Now Q1 will become 10, Q2 will become 10. They can share equally from the total. So I can say 10 into 10. Then take this ratio. Directly I am taking here. It is like F by F dash, because they are asking initial to final. Initial is F, F dash is final. Yes, S Nostra. Yes, good. You're good. Option 1. So it is being like 800 by 100, na? So 8 is to 1. It should be. I hope you understood how the charge distribution takes place between the bodies. You must take first of all total charge that can be shared equally. In place of minus 20, if I give plus 20, total charge becomes 60. Then each can share 30-30. Okay, you should keep in mind these points. If charged bodies are in contact, charge distribution takes place. Charge can be shared by each body equally. Till then, that is the limit. Charge transfer takes place till they become equal. Clear? Yes. Yeah. So about Newton's, Coulomb's law between the charges, how to find if charges are magnitude of charges changed and separation changes, we have seen the questions. And let us see how to find the net force on Q due to system of charges. Let me take here one example. Please all of you observe this. You can see here along x-axis infinite number of charges are placed. Let me take, so to find the net force on any charge due to system of charges will be like you need to take sum of the forces. Okay, now you can write, I'm writing here at 1 meter distance Q charge, and at 2 meter distance Q. All are identical charges only. At origin also Q only. So on infinite number of charges. Nazir. 0 or equal is about, let me change the distance. I'm giving like 1, 2, 4, 8, like this. Separation of each charge from the origin given, and all are identical charges, like that there are infinite number of charges. Now I want F net value. F net. At O. At O there is a Q charge due to remaining charges. Due to remaining charges. So at O due to remaining charges, you can follow F net value equal to sum of, according to principle of superposition, because all are identical na. At O due to first charge, it will be repulsive because both are same charges. Due to first charge na, I need to give direction this way, sorry. And at O due to second charge also repulsive, and at O due to third charge, which is at 4 meter distance, is also repulsive. So due to third charge at O, repulsive force means it will be repelled by that charge because of similar charges. So I can take directly F net value, which is equal to F1 plus F2 plus so on, infinite number of charges. Yes, no? So if I apply Coulomb's law between origin to first charge, origin to second charge, that way there is a common term, that is kq square. Only separation is different because charges are same. Charges are identical. Okay. Origin దగ్గర q charge undi. At separation also q charges only. Yes, no. So kq square into, if you take common 1 by r square term, Like 1 by 1 square means 1 only will come, plus 1 by uh, 2 square, plus 1 by 4 square, plus 1 by 8 square, plus so on infinite. It is like numbers are in increasing order in a particular sequence, and there is a common ratio. So we can use the technique from the mathematics, taking geometric progression for sum of infinite terms. I can write it as 1 by 4 plus 1 by 4 square. 2 square I'm writing it as 1 by 2, 4. And 1 by 8 square I'm writing it as 4 cube. 1 by 4 cube. So I just made, is the red color ink okay? Okay. Kq square into, for sum of the infinite terms, if I take geometric progression, it should be first term by, first term is 1 by 1 minus common ratio. Common ratio is 1 by 4. So it will give you 4/3 of kq square. Okay. So if all the forces are in the same direction, you can just add up. If there is angle, please come to this figure where I kept 2. If there is angle between the forces, here the trick we can apply from the vectors to find the resultant force between, if there is an angle between any two forces, you need to take F1 square plus F2 square plus 2 F1 F2 cos theta. This is from parallelogram of vectors. If, and one more short trick is there here, if F1 equal to F2 means their magnitudes equal, then the resultant you can use it as 2f cos theta by 2. Now let us solve this question. There is an equilateral triangle, let the side is A. Now I am going to find the F net at any corner due to remaining charges. You can observe in the diagram, I kept equal charges at all corners, plus Q plus Q plus Q. Okay. So in the diagram I already given direction of the forces. Due to corner B at A, there is a repulsive force. Means corner A charge will be repelled by the corner B. So direction is this way. You can see here. And at A, due to corner C also repulsive only. Now force between A and B, force between A and C with the direction is having 60 degrees angle between them. And I can say here force at A due to C, force at A due to B equal. Because separation is same, charges same. Here Q only, here also Q. And between C and A also, between Q, Q and separation is A only. So can we say their magnitudes equal? What is that magnitude? It should be KQ square by A square. That is the magnitude of the force between A and B, A and C. But they are having angle between them and magnitudes are equal. So directly this is short trick you can apply. That is resultant force equal to 2f cos theta by 2 where magnitudes of vectors are equal. Here force is a vector. So can we write resultant at A due to B and C should be 2f cos 60 by 2. Is it? Cos 60 by 2 వాల్యూ ఏమవుతుంది? F వాల్యూ ఎంతో ఇచ్చాము ఆల్రెడీ. So it is kq square by a square into cos 60 by 2 means cos 30. Cos 30 value, it is root 3 by 2. అవునా? 2 to cancel, ఆన్సర్ వచ్చేసి మనకి root 3 k q square by a square. Okay. So this is one of the type. One compulsory question we can expect about the net force at any point due to system of charges. The same model about electric field intensity also. Same model questions. Electric field strength మీద కూడా సేమ్ మోడల్ క్వశ్చన్స్ మనం ఎక్స్పెక్ట్ చేయొచ్చు. సో ఒక అడ్వాంటేజ్ ఉంది. One of the question compulsory from these models and about a force లేదా ఎలక్ట్రిక్ ఫీల్డ్ స్ట్రెంగ్త్ గురించి కూడా అడగొచ్చు. సింపుల్ గా మనం ఇక్కడ యూజ్ చేస్తుంది టెక్నిక్స్ ఆఫ్ వెక్టర్స్ to calculate the net force. If the forces are in the same direction, we are adding. If they are having angle, we are using techniques of vector. And one more concept, if the system is in equilibrium, if the system is in equilibrium, so ఏవైనా two charges ఇచ్చి to keep the system equilibrium, how much third charge we need to keep between them? Those type of questions can be expected. ఇన్ కేస్ ఎప్పుడైనా సరే సిస్టమ్ టు బి ఇన్ ఈక్విలిబ్రియం అని క్వశ్చన్ అడిగారు అంటే వీ నీడ్ టు టేక్ సమ్ ఆఫ్ ద ఫోర్సెస్ ఈజ్ ఈక్వల్ టు జీరో ఇన్ దట్ సిస్టమ్. నెట్ ఫోర్స్ షుడ్ బి ఈక్వల్ టు జీరో. ఆల్జీబ్రిక్ సమ్ ఇది మనం లాస్ ఆఫ్ మోషన్ లోనే నేర్చుకుంటాం. హౌ టు టేక్ సమ్ ఆఫ్ ద ఫోర్సెస్. ఓకే, so let us try those model and keep in mind this point, if the system is in equilibrium we need to apply the condition sum of the forces should be equal to zero. Applying this condition you can find one of the charge, what should be the magnitude of the charge to keep the system in the equilibrium. Okay, let me take similar way electric field intensity also. Till now we measured net force or force between any two charges. Similarly, what is electric field intensity? See here, electric field intensity, it is also called as electric field strength. Please follow this simple example. We are having Q charge. Yes, na? Surrounding of this charge up to some region. అంటే ఫర్ ఎగ్జాంపుల్ మీ ఏరియాలో మీ స్ట్రీట్ చివరి వరకు మీకు తెలిసిన వాళ్ళు ఉంటారు. సో వాట్ ఎవర్ యూ సే దే కెన్ ఫాలో, దే లిజన్ యూ. మీ స్ట్రీట్ దాటి వెళ్ళిపోతే నీ మాట ఎవరు వినరు. ఎస్నా? సో దట్ ఈస్ యువర్ రీజియన్. అప్ టు దట్ రీజియన్ యూ కెన్ డూ ఎనీథింగ్, యూ కెన్ టెల్ టు సంథింగ్ టు ఎనీవన్. యా, similarly this charge surrounding of this region, it can affect the other charges. For example, I kept Q naught charge in the region of Q. So this Q naught will experience the force. If they are same charges, it will be repelled by it. If they are opposite charges, it will be attracted to that. That way it experiences the force due to this field charge. Field is nothing but the surrounding place only, it's a field. Okay, now I want, so at this, let this point is P. I want electric field strength at that point. Now I need to take force between them by, at that point which charge I placed, that is Q naught. So I have to write force between them is K Q naught by, let the separation is R square into Q naught. So by taking F by Q naught, it gets cancelled. Finally, electric field at any point is equal to KQ by R square. That means it depends upon the field charge, not that point charge. You got my point? It depends upon the field charge, not the point charge. Let me ask you simple example. Please all of you come to below here. For example, there is 2 microcoulomb and 1 microcoulomb charge which are at 2 meter separation. Okay. Now I want electric field at 1 microcoulomb. Then what can you write? It is equal to K into 2 into 10 power minus 6, because micro is 10 power minus 6, by 2 square means 4. I did not take 1 micro. Did you understand that? So it depends upon the field charge. Now the field charge is 2 microcoulomb. So at 1, due to 2 microcoulomb means we take 2 into 10 power minus 6 by 2 square, which is equal to 4. Okay. And we must be careful with the how to give the direction of electric field. We are finding at any point electric field strength due to some charge. For example, if there is a positive charge, direction of the electric field will be away from the charge. If positive charge presents, it appears away from the charge. If negative charge presents, towards the charge. This way you need to give the direction of the electric field. Okay. And if they're asking by giving the electric field present at that point, if they're asking what is the force experienced by that charge, you can take F equal to Q into E. Nothing but that point charge into E. E is nothing but electric field value. And sometimes they can give you field present at that point and direction of the force. So there is a field right direction, E bar, and plus Q charge is kept in the field. Then it experiences the force in the direction of the field. Please follow that point. Plus Q charge present in the field, it experiences the force in the direction of the field. If negative charge present in the field, you can observe second diagram, field is right direction only, but negative charge is present in the field, it experiences the force opposite to the direction of the field. So if they ask direction of the force where the charge kept in particular field, okay. Now, yeah. Similarly, same as how we calculated net force here also, using superposition theorem, net electric field will be E1 plus E2 plus E3 so on. If there is angle between the two electric fields, same under root of E1 square plus E2 square plus 2 E1 E2 cos theta. Let us discuss one question. How to give the direction of electric field and how to give at any point electric field strength value. There are 2 point charges Q and minus 3Q are placed at some distance apart. If the electric field at the location of Q is E, then at the locality of minus 3Q it is. First, let us analyze the situation. There are 2 charges. Let the separation is AB, like at R distance. Okay. Here Q charge, here minus 3Q charge. Now they are saying um, electric field at the location of Q is E. So can we write E at Q is E only, that is equal to, I need to write K into 3Q by R square. And in which direction? At Q due to negative charge. E at Q is nothing but at point A. Yes, na? No, Shra, you are giving answer E by 3, yeah? Good, good, good. Yeah, need to understand the direction also. Due to negative charge at Q, it will be attracted. So electric field E will be towards negative charge now. Now they're asking E at B, nothing but at the locality of minus 3Q. Minus 3Q due to positive charge. So due to, let that is E dash. So I can say direction is towards negative charge only because we are finding due to positive charge. Due to positive charge, direction of electric field appears away from that. So it is away from A and towards B, like that. So it will be equal to K into Q by R square. So it is along AB direction, first one. And second one, I can express in terms of the above. So multiply and divide, it gives you 3, sorry, E by 3. Because 3KQ by R square is E. It is E by 3. It is also along AB. So answer should be E by 3. Both are in the same direction. If you substitute with the sign also, you will get the same. E by 3 only. At AF, you can give like it is minus E. Minus of minus, E dash will become plus E by 3. That way. Yeah. And let us observe few more. In case if there is angle between two electric fields, you need to follow techniques of vectors. Here we are given with some system of charges which are located at corners of equilateral, at corners of a square, that way. Um, Please, all of you look into this diagram. First diagram, it is an equilateral triangle system of side A. By this, due to the symmetry of the charge, you can say net electric field at center is 0. So in the first 1 and 2 figures, they're asking at center due to corners, what is the net electric field? Okay, let it is A, B, C. I can say at C due to A will be the away direction of electric field is away. So EA. And due to B will be in this direction. And due to C will be in this direction. And all these vectors in this uniform figure, they lies at an equal angle. I can say in this system angle is like 120, or you can follow Lami's theorem. According to Lami's theorem, there are 3 equal or unequal coplanar vectors are required to keep the system in equilibrium. System in equilibrium means E net value 0. That is what at the center, due to similar charges which are at corners, the net will be 0. If different charges present, of course, you need to follow the method again. Similarly, there is a square, all equal charges at the corners. At the center, E net value will be 0. Undoubtedly, you can say. So remember, due to the symmetry of charge, net electric field at center is 0. And here we are given with one question. Come to this third. Q, 2Q, 3Q, 4Q charges are placed at the four corners A, B, C and D of a square. Let it be. This is C, it is D. At C, how much? 3Q. Here 4Q. Like this, these are not similar. If they are similar charges, you can say at center E net value 0. So different magnitudes of charges placed at the corners of a square. The field at the center O of the square has the direction along. They're not asking magnitude, they're just asking direction. Okay, come here at center. whenever we are finding electric field at any point, at that point, whatever charge, it does not depend on that. So if charge is given, okay, charge is not given, you always assume if unit positive charge present at that point. Okay, now you can see due to corner A at center, that is O, electric field will be in this direction like EA, yes, na? And due to C will be away from the charge, so away from the center. Due to D at this point also away from the center, that is corner D. And due to B at this point also away from that point, yes, na? Now net electric field. So from the vectors, we know that if any two vectors are in opposite direction, it can be subtracted. They are in the same direction, it can be added. If they are having angle, we have the under root formula. Here they are in opposite direction. So can we say the subtraction of EC and EA will be in the direction of EC. So EC minus EA will give you magnitude of 2Q charge. And again, E EDB, because at corner D 4Q, at corner B 2Q, if you take the subtraction, finally magnitude of charge we will get 2Q only, and the resultant will be in the direction of ED because it is greater. ED direction is like this. So finally ECA and EDB resultant will be in this direction. It is being which direction? This direction, it is along CB. Yeah. So option should be along CB. So of the square at O, it has the direction, net electric field direction finally will be along CB. Just a direction they're asking. Okay. Yeah, students, let me discuss a few previous year's model questions based on these concepts. So you all have known in the Spark Academy, in very reasonable price, there are two programs they have launched, Poratam or Yuddham. It's very lowest price. You can contact about that batches. You can contact to this number. You can call 9133380172 or 8977525461. Okay, for admission purpose for that Yuddham or Poratam batches, which are very helpful for the students. And I need to say here, why Spark Academy is special, why it is different from the others. It should be mainly based on these points. Actually, I need to say the guidance also. Personalized coaching with a dedicated helpline and post-exam counseling guidance is also included. It is very, very important. Many students are having many doubts in that. Yeah. And this one. Okay. So this is our methodology which we follow with the basic concepts, shortcut methods, model questions, exercise questions, previous year's questions, chapter-wise tests, weekend test, grand test, and analysis can be given. Yeah, let us discuss few questions based on that concepts. Mm, you can try. I can explain few. Few you can try, which I can give you now. There are 5 point charges, each of value plus q, are placed on 5 vertices of a regular hexagon of side L. What is the magnitude of the force on a point charge of value minus q placed at the center of the hexagon? 5 charges placed at the vertices of a hexagon minus q charge. Actually, it should be minus q is placed at the center of the hexagon. So we can know that at the center, due to similar charges as per the direction of the electric field, so let it be 1, 2, 3, 4. First, I am taking these four corners. So E3, E2. Similar charges at the center, due to similar charges, the direction is being opposite. So E2, E3 gets cancelled. The net due to E2, E3, and even E2 gets cancelled. Even E4, sorry, it is even E4. Oh, middle one is minus charge, no? So it should be due to fourth corner, it is E4 only, it is E1 only. It is always towards it, no? Like that. Anyway, as per the direction, at this point, due to this charge, attractive force that way, in the direction of the force only field. So E1 and E3 gets cancelled. Their net will be equal to 0 due to these two directions. E4 and E1 also, their net will be equal to 0. So there is a final resultant due to the fifth charge at this corner. So I can say here K into Q into minus Q, of course. Direction they did not ask, just they're asking magnitude of the force. Should be minus actually, KQ square by, like, let the side length is like L. So you can say L square. So minus KQ squared by L square it will be. Yes, now? Nostra, you're giving answers very fast. Good. Very thorough with this chapter. Huh? Yeah. Let us solve this question also. If a charge Q is placed at the center of the line joining two equal charges Q such that the system is in equilibrium, then the value of Q is. They have placed a small charge Q between the two charges. Let two charges Q. So to keep the system in equilibrium. Actually, one more point you can understand here. Whenever the system is in equilibrium, if we place any charge at the neutral point, let it is X, neutral point, from any charge you can consider. Um, that should be equal to distance between the charges by under root of Q2 by Q1 plus or minus 1. It is the formula to find the neutral distance between the charges. Because if we are placing any other charge at the neutral point, you can keep, especially three particle system, you can remember this formula. Okay. For example, these two are at a distance d. So exactly at half of the distance, if you place the third charge, it can be in equilibrium. Equilibrium means at this point, sum of the forces, actually they're asking, yeah, sum of the forces here will be 0. This gives sum of the electric field at that point will be 0. That is the condition you need to apply to find the magnitude of that third charge which is placed between them. Okay. So this is the formula, especially three particle system, at which point we need to place to keep the system in equilibrium means undoubtedly you can go with neutral point. If you place third charge at neutral point, system can be equilibrium. But they're asking here what is that third charge value. To find the third charge, take sum of the forces equal to 0. And I can take here when Q is in equilibrium at that point and it is from the first charge. So you can apply here this condition. This is the third charge. Force between 1 and 3 equal to force between 1 and 2. Then automatically you can find the third charge. Or you can apply um, F13 plus F12 equal to 0. Now try it is option D. Yeah? Good boy. So I'm applying Coulomb's law between 1 and 3 and 1 and 2. So you can say here between 1 and 3 it is K Q into Q by, whereas it is D by 2 whole square plus K into Q square, because between 1 and 2 na, by D square equal to 0. Yes. So we get K Q square, 4 will come here by D square equal to minus K Q square by D square. D square cancel, K cancel, 1 Q cancel. So small q, the magnitude of that third charge to keep the system in equilibrium, it should be minus q by 4. Yes, option D correct. By applying this condition also, you can find the same answer. Okay, the point you need to remember, especially two particle system, at the neutral point if you place third charge, it can be in equilibrium. Then we are finding that distance from one of the charge, that charge will be in equilibrium, then the whole system will be in equilibrium. That is the meaning. Okay. Yeah, you can try this question. Huh? There are 4 charges. Please write down and try equilibrium. Mm, oh, no, Sri, you can give answer for this also. 4 charges equal to minus q are placed at the 4 corners of a square and charge q is at its center. Like this. Similar charges. At the center, q charge. Okay. If the system is in equilibrium, the value of q is. So you take at any point due to other charges, take the net value, then equate with 0. Either force or electric field strength, whatever. I'm asking, let this is A, B corners, corner C, corner D. Find, I'm giving the clue just, find E net at C. And center charge is fifth charge. Due to system of charges. And equate that net value 0. Because they are in equilibrium. Now try, you're giving it is option B. Is it? Is that exactly option B? Plus only, yeah? Are we getting plus only? Yeah, because when there are all positive charges, third charge we are getting negative. Here all negative charge, so fifth charge should be negative. Magnitude might be equal, but we get opposite sign. Yes, you are correct. That logic you can apply. Okay, at corner C, due to this corner, due to this corner, due to this fifth charge, all let the side length is A of this square, then you can try. Nostra has given already answer. It is correct. Good. Lastly, and lastly, try this question also. An infinite number of point charges, each carrying 1 microcoulomb charge, are placed along the y-axis. at y equal to 1 meter, 2 meter, 4 meter, 8 meter. The total force on A, already I explained this model. Ah, yes, no, I understood. Because all corners all negative, so fifth charge should be positive. Yes, yes. You applied that same logic. Huh? The total force on A, 1 coulomb point charge placed at the origin. Remaining all are 1 micro, it is 1. Placed at the origin is x into 10 power 3 Newton. The meaning F net value they given at let it be O, at O is given x into 10 power 3 Newton. What is this x value they're asking? So you find F net due to system of charges. I think I can write like k into 1 into 10 power minus 6 and take the separation. 1 plus 1 by 2 square, yeah, plus 1 by 4 square, 1 by 8 square, plus so on. It is JEE model, numerical solving type question. So which is given in 2021. So find this answer also. Same model I explained, but I did not mention the charges. Equal charges I given. Is it? I think there we got 3 4 by 3 times, 3/4 times of kq square. Direct that formula you can apply. But it is not q square here. One charge is 1 c, other charges are 1 micro c. Of course, 1 square into 10 power minus 6. Okay. So these models compulsory you have to practice, compulsory one question students. I hope you all understood. Okay. You can join for the live classes, be up to date. You can contact for any updates 9133380172 8 or 8977525461. Nostra, you got answer. 12, magnitude of x. Exactly. Good, good, yeah. Good, Nostra. Okay, students, thank you. We will meet in the next session. Mm. Yes, yes, exactly. Into 10 power 3 will be there now? Yes.